All right, as we continue on, just a very quick review. Remember what we did yesterday. We started with this, all right, where literally all that we had in here were hard-coded values. You learned how to create variables. This program showed you that there were, two of the different types of variables that are available in JavaScript, those being strings that, again, can be within either single quotes or double quotes. The reason I normally use double quotes, if you care, is most programming languages only allow strings to be created in double quotes. All right, not all, but most. All right, from there, after we hard-coded in these 5 values, or hard-coded in 4 of the 5, we just said the 5th one, the gross pay, was equal to the hours worked times the hourly rate, and then we did an alert to print all of the information out. The question got asked yesterday, what's a \n? And again, that's a carriage return line feed, so it's like you hit the enter key. All right. The other thing we looked at in here, a couple more things, the plus sign that you use for concatenation or gluing things together, and the to-fixed, to put things to 2 decimal places, and you also learned that JavaScript is a case-sensitive language. All right, so you learned all that stuff in that first program. Then we went on, and the next program didn't have much more in it, but it had a little bit. Those being the lines that you saw right here. And you learned about the built-in JavaScript function that was called prompt. All right, and actually we did 2 different prompts. When you want to do a simple prompt and have a string value, it's just prompt. If you want to do a prompt and you want to take that value that's naturally put in as text or as a string and convert it to something numeric, you use parse float. There's also something called parse int. And I didn't mention this to you yesterday. It's not like it's that big a thing, but one of the things that makes JavaScript kind of unique, when this comes up with this parse float in here, you saw this yesterday, but you had the box that came up, and it said enter hours worked, and it had just a default in there in the box where it said hours. And it was all already in blue, so as soon as you started typing, it was replaced. Now, not like this is a big thing, but I want you to understand this. If I come in here and I type in 123.456, and then I fat finger and I accidentally type in A. That makes sense? And I didn't do it on purpose, but I typed in 123.456A. It'll still work. It throws away everything that you type in after the last digit. So if you do, I could type in hello here, and it would still work. Now, that's only if you put the illegal digits at the end. So if at the beginning, I had put hello 123.456, then it would actually assign to hours worked NAN. We learned about that yesterday too, it being not a number. All right. So it's a little bit more forgiving than most languages are, just so you know. Other than that, other than the prompts here, this was the same program as the first one that we did. All right. Then we went into number 2, where we added the if statement. We also added constants here. And again, I do want you to understand, you can Google this, bless you, if you want to, but the support of constants in JavaScript over the years hasn't been that strong. And what I mean is, if you declare in other programming languages, if you declare something to be a constant like this, and you try to change it in other programming languages, you get an error message. JavaScript typically does let you change the value of constants. So you'd say, well, then what the heck is the value of putting and then there is a constant. There isn't a whole heck of a lot. All right, I know plenty of JavaScript programmers who make everything vars, even their constants, but they take those vars that they want to use like constants and put them in uppercase. Okay? All right, so we added those. The maximum number of hours you could work without getting overtime, which was 40, and our overtime rate, which was 1.5. Those were arbitrary values, but they pretty much are reflective of the way it is. All right? And then we added into here a couple more variables. We added reg hours and OT hours. We didn't have to do that, but again, I did that because just to show you, you know, different ways that we could do this. All right. Then we came in, and this was new in here, and that was this if statement. All right. What I do want you to understand is this, we said here, if the person worked more than 40 hours. All right. And you should all understand, everybody in here should get this. This is greater than. So there's greater than or equal to, less than or equal to, which is the double equal sign, and not equal to, which is an exclamation point followed by an equal sign. Now in some programming languages, you can do it like that, or you can do it like this. I believe JavaScript only allows you to do it this way. All right? And as we talked about yesterday, when you're checking for equality, it's two equal signs, because if you only put in one, it's assignment and not equality. All right? So we said if you did work more than 40 hours a week, your regular hours are 40, because that's the number that you worked that weren't overtime. Your overtime hours were the hours that you worked minus 40. Okay? And then our gross pay, hopefully everybody understands what's in gray there, that's our straight time. Right there, that's our straight time. All right? And this is our overtime right there. Now, let's say that we did this and we didn't want to make a variable called reg hours and we didn't want to make a variable called OT hours. Everybody with me? So we don't want to make those two variables. Could we have still done this? Well, of course we could have. But then, and I'm going to just put this in, but I'm going to comment it out. We could have said something like this. Gross pay equals, and the first thing we would have wanted to do would have been our regular pay. So it would have been what? We could use, since it's 40, we could just have said max non-OT times hourly rate. Does that make sense to everybody? That's our straight time. We know they worked over 40 hours. So this is 40 times their regular rate. That would work. We could do that. And then we would add to that. I'm just going to put it on another line so you can see it. Well, the first thing I would have wanted to do would have been to say, well, the hours that we worked minus that max non-OT. Okay, that would have given us our overtime hours. And we could have done that times our hourly rate times our OT rate. So what I'm trying to show you is we didn't have to do it by creating other variables. The reason I created other variables is I figured this might be easier for you to understand than this. All right? It may be, it may not be. All right? But hopefully you can look at both of these and realize they're both doing the same thing. So again, let's plug in values. Let's say that you work 50 hours, and let's say that you make $10 an hour. All right, looking at it this way, the gross pay is what? The regular hours, which we already said was 40, so that's 40 times 10, all right, plus the OT hours, which was our regular hours, 50 minus 40, which is 10, times our hourly rate, which is 10, times their overtime rate, which is 1.5. And even if I put it in like this, it would still work without the parens, because you do multiplication before you do addition. So it's going to do this, and it's going to say 400 here. 10 times 10 is 100 times 1.5 is 150 here, and then it would add them. Okay? And if we look at doing it this way, we would have said what? Again, 40 times 10, which is our hourly rate. All right? And did I not have a plus sign in here? I would have needed one. So plus, and again, hours worked, 50 minus max non-OT 40, which would again given us 10 times our hourly rate, which again was 10, times the overtime rate. So we should get the same value. That's what I'm trying to get across to you, that there's two ways, and there's plenty of other ways we could have done it also. All right? But either one of those ways, and either the way I just put down or the way we did as a class, either one of those ways should work. All right, so those were the first two. So the first three. The first one we hard-coded. The second one we had the prompt. Those just demonstrated sequence. It was one line after another. There was no deviation in what we did. The third one we did, which was payroll iteration 02, had the if statement in there. That was selection. And then the third one that we did, we added additional variables, those being our total employees, our total gross pay, and the ability to replicate or repeat the program. That was the third part of structured programming. So we looked at selection, we looked at iteration, we looked at sequence and selection. This was iteration, looping, repetition, whatever you want to call it. All right? So we did this. We put almost all of our code into this loop that says while keep going, which was a shortcut for while keep going equal true. Remember, with the double equal sign. And we mentioned this yesterday, if we'd have put this in, that is always true. Because it just says, can you assign true to keep going? Yes, you can. All right. So that's assignment. That's an equality check. All right. So we wanted to go in, and then this was all the same stuff that we were doing before. Everything that you see in here, all of that stuff, that's the same stuff that we copied over from the previous program. Then we had our new stuff. We talked about the fact that when you want to add 1 to a variable, there are 4 different ways that you can do it. I showed you those 4. All right. We haven't talked about the plus yet. We will when we get to the book. All right. And I just happened to use that one. Again, we could have said total employees equal total employees plus 1, or any of these other ones. And then we added to our gross pay. Things that I started with tote, as I mentioned, are called accumulators. All right. And then finally, we asked the user, do you want to run the program again? Okay. And what we did was, this is an older copy. I guess all I've got in there is that. But we looked at it, if you remember, we came in, and I've got the other copy right here. Okay. So we came in and we said, after we said again equals this, we came in and we said again equals, and we used the again dot char at 0.2 uppercase. And that gave us just the first character, and that uppercased that character. All right. Then we checked that character, and if that character was a Y, we set keep going to true. Otherwise, we kept keep going, or we set it to false, meaning we were done. Does all that make sense? Is there anything that we did yesterday that people have questions on? All right. I've got all those lectures from yesterday. I forgot to put them out on YouTube last night. Again, more for Jesse, and it looks like he's not here again today. All right. So what I'd like you to do is bring up payroll iteration 4, but before you do that, make sure you've got payroll iteration 3 up also. Did you hear what I said? So what I want you to have are 3 different files open. Okay? I want you to have your test 04 file right there. I want that file open. And then we're going to be constantly copying information from our iteration 3, because we've got all the code in there, to our new iteration 4. Unless you really want to go and retype a lot of code, which probably most of you don't. All right, I know I don't. The good news is there's virtually nothing we have to type in that's new. All right? When you have a function, and there's examples here of functions, ideally, a function is a self-contained piece of code that's designed to do one task. All right? That's the ideal. Now, I tried to write this more using the ideal. And what I mean is, if you remember, we're asking the user their first name, their last name, their hours worked, and their hourly rate. I think you'd all agree with that. We're asking the user those 4 pieces of information. And if you notice, input first name, input last name, input hours worked, input hourly rate. All right? So what we're doing is we're writing a function for each one of those. Does that make sense? But we're going to add some error checking code in here. All right? And we're going to look at that in just a minute. And then we calculate the gross pay. That's another function. Then we have our alert statement. That's another function. Then at the end, we have when we alert the alert for our final totals. That's another function. So we've got a function for the first name input, the last name input, the hours worked input, the hourly rate input, the gross pay calculation. So this is an input. That's an input. That's an input. That's an input. Then we have our, let's just call it IND alert. So for that person, IND alert, that's an output. Then we'll have our final alert, which is going to have our final totals in it. That's an output. Do you understand the distinction between an input and an output? You know, it's if I say, how you doing? And you answer me. All right? You're inputting information. Okay? If I write down your name and how you're feeling, I'm outputting information. Okay? And the whole idea here, what we're trying to do is we're trying to take our inputs, process them, and give us our outputs. Okay? All right. I'm going to do something. This is even more than, because I've got like a little cheat sheet here, but I'm going to have even more than what I told you guys. Now, this first example that we create, please listen to this. The first example that we create, right here, this example 4. This example, we're going to use functions, but we're not going to put anything in the parentheses. All right, I've used this example before, and sometimes people get it. Sometimes they look at me like I got a screw loose. But let's assume that I've got an 8-year-old child, okay? And they leave. I don't have an 8-year-old child, but they leave. They go to school, and I go in, and I'm going through the house, and I look at their room, and it's just a pigsty. I mean, it's unbelievably bad. So they get home, and we're going to assume that this 8-year-old is also a little bit of a smartass. All right? So they get home, and I say, get in here. And I look at them, and I say, clean the room. What are they going to say in answer when I say that? What's their answer probably going to be? No. Well, no would be a natural one. But if I say clean the room, what are you going to say? What else? What room? They might have also pigged up the bathroom. All right? I mean, I've got 2 kids that still live at home, and they're 25 and 21, 26 and 21. And it's unbelievable. They're both girls. And I've told this to my wife. Girls are much bigger pigs than guys are. It's not even close. My wife said, that isn't true. Well, how long does it take a woman to get ready as opposed to how long does it take a man to get ready? I mean, you know, she always says, oh, you didn't do this, you didn't do. I always take my dirty towels and whatever. They never do. All right? The point is this. If I want to put some information in those parentheses, that information, the one or more fields that I put in there, those are called parameters. I don't want to use parameters in this example. Did everybody hear that? The reason that that's important is since I'm not going to be using parameters, I'm going to make everything in my program global, which means it's known everywhere. in the past, what we've always done is we've declared our variables in here. Would you agree with that? Right inside of Maine? But if we create them in Maine, they're not available to every other routine unless we do what's called pass them into that routine. That's what we're going to do in the next example. But for now, all right, we are not going to have, we're going to make all of our variables global. How do we do that? Go back to your lesson 3 and grab everything, grab all of your constants, and grab all of your variables. All right? So grab all of those 2 constants and those 10 or so variables. Copy them to the clipboard. Go back over to payroll 4, but please look on the screen here. Paste them in above Maine. Paste them in above Maine. By putting them up above like that at the top of the program, above where Maine is, they are now global constants and global variables. Everybody hear that? All right, you have to understand the distinction. So I'm going to even put this in here. Global constant declarations and global variable declarations. All right? We're also going to add a little bit more. I don't know if if this has bugged you, but it's sort of bugged me in that right now the program, if we put in garbage or if we leave a field blank for one of those numeric fields, we get NaN, correct? I don't want to do that anymore. Not only that, I could say that the person worked negative 63 hours and they make $10 an hour, which means they owe me $630. That isn't right either. So to do that, we're going to create more constants. We're going to create a minimum number of hours they can work, a maximum number of hours they can work, a minimum pay rate they can have, and a maximum pay rate they can have. Does all that make sense? All right. Before we do that, let's just think about it for a second. I'm going to say the minimum hours somebody can work are 0. Maybe they're sick. Okay? Maybe they're on vacation. So I'm going to come in here and I'm going to add a new constant, and I'm going to call this min hours, and I'm going to set that equal to 0. And I'm going to say here, minimum hours, spell it right, employee can work. And I'm also going to come in and I'm going to say, you know what? Although sometimes we think we're Superman, Superwoman, we're not, all right? And they've actually done studies that when people work more than like 12 hours a day, after a few days, their productivity goes way down. It's just natural that that would happen. But we're going to assume that the maximum hours that you could work are going to be 84. So the minimum hours you can work are 0. Again, you're sick, you're on vacation, I don't care. Okay? The maximum number of hours that you can work are 84. Does that make sense to everyone? Because now what we're going to do when we go in and we check the hours worked, if what we put in there is not a number, we can handle it, but we can also handle out of range input. So putting something non-numeric in there, and please listen, you don't have to look, but please listen. Putting something non-numeric in for hours, all right? That's not a range invalidation. That's basically a type invalidation. I'm looking for a number, I put in something non-numeric. But if I say now my range is 0 through 84, and I put in a negative number, or I put in a number greater than 84, that's an out of range error. Do you understand the distinction? All right. So let's do the same thing with, we'll call it rate. So I'm going to have min rate, and I'm going to have max rate. Now the minimum rate I'm going to keep that at 0. All right. Maybe the person's, a volunteer. They just got a lot of, time on their hands and they go to work for the place. How about for the max rate, let's just put it at, I don't know, how about 100? Let's say that the person there who makes the most money makes $100 an hour. Again, and I'm sure you all get this, these are arbitrary values. If we had to change it, we could make it 250. We could make it 1,000. That's not really important, all right? But I do want you to understand, we added in there, we added 4 constants. And we added 4 more constants to handle range validation. Does that make sense? All right. Since I'm not hearing no, I'm assuming it does. All right. So we've got our global constants now. We're up to 2, 4, 6 of them because we just added 4. We've got our variables, 2, 4, 6, 8, like 10 or 12, somewhere around there, maybe 11. So we've got all those. Now we've got Maine. Maine in the past is where we have done all of our work. Everybody hear that? That's what we've done. We've done all of our work. All right? Well, we don't want to do it that way anymore. Okay? What we want to do in Maine is have as much as possible. We want Maine to be a driver. Now, don't type this in. Please don't type this in. In an ideal world, we type in this. Input first name, input last name, input hours worked, input hourly rate, calculate gross pay, and what is it? It's called, where is it? Output IND payroll info. In an ideal world, that's what we do in Maine. Now, Maine is a total delegator. Does that make sense? That's all it's doing. But we can't do that. That would work fine if we only had 1 employee. But you already know we want the ability to run this program multiple times. All right? So, what I want to do is, I'm going to keep those here for right now, and I'm going to come in here as we've done, and I'm going to say while, keep going. You already saw that. Do I have to type this in again? While, keep going, equal, true. Okay. It's a shortcut. We learned that before. All right. And we want our curly brace. Okay. Then we can actually, I'm going to get rid of the one that outputs the individual information. In fact, I think I can probably leave it in there. It looks like I left it off. All right, but I'm going to grab all of this stuff. I'm going to tab it over, and I'm going to come in here like this. Okay? Maine is now looking pretty much like a driver. All right? The problem is, it's going to keep going forever because I'm never changing the value of keep going. So I still have to put my code in there that's going to do this. All right. So I'm going to say, again, equal. In fact, we have that over here. I think we do, don't we? So I'm going to grab all of that stuff that we had before. I just don't feel like typing it again. All right. So now what are we doing? Well, while keep going is equal to true, we input the first name, we input the last name, we input the hours worked, we input the hourly rate, we calculate the gross pay, and we output that individual person's payroll info. Then we ask if they want to run it again. If they enter with a Y in the first character, we set keep going equal to true, and we'll go back all over and do the same thing all over again. Does that make sense? All right. Again, I'm asking to people, what we're doing here, does what we're doing here make sense? Made it a little smaller so you can see everything on the screen. All right? So you can go ahead and put that in. Now, don't run it afterwards because there's no code in any of those 6 routines that are up there. We're going to put that code in a minute, but I want to show you something before we do. So I kept this, I made it small, I realized, but hopefully, Christopher, you can still see it, and Matthew, you can still see it from back there, because I wanted you to be able to see everything. All right, so I'll give you a minute or two to key that in. These lines that are right here that are now in gray, if you don't realize it, those lines are referred to as function calls. I am first calling the input first name function, then I am calling the input last name function, then I am calling the input hours worked function, then I am calling the input hourly rate function, then I am calling the calculate gross pay function, and finally I'm calling the output IND payroll info function. So those are 6 function calls. All right. Technically, this is a function call as well in the green. Okay. Technically, so is this. And technically, so is this. All right. Why do I say on these, why do I say these here at least are technically? Because when you've got the name of something dot something else, those, when you use the dot syntax like that, that's typically referred to, those are methods. All right? And what's the difference between a method here and a function here? A method is called on what's referred to as an object. We're not going to really talk much about objects. That's just one of the chapters we don't have time to go through. All right? So right now, we still have to write the code. I think everybody'd agree with that. We still have to write the code. All right, but if you look up on the screen here, there's Maine. Inside of Maine, we're doing all this stuff. So all this is being done in Maine, every bit that's there. Does that make sense to everyone? Eventually, we fall out of Maine, correct? We want to, otherwise we're in what's called an infinite loop. Okay, but let's say we've got 5 employees, so we put in those 5, and then we say, do you want to keep going? We type in an N or the word no. So now when we get to the bottom, when we're all done, now we want to output our tote payroll info. But it's very important with this line right here, it's very important that you all understand that we don't want inside of our while statement. Because otherwise it's going to be printing out final totals with every time we put in an employee. We don't want to do that. We only want to print out final totals when we're finished putting in the input for all employees. Okay? Does all that make sense? So we could put comments in here for all of these. But I tried to use names. I mean, I don't know why you'd want a comment here that said input the first name. because that's what it's called. So in my opinion, good, bad, or indifferent, those names, those first 5, are pretty reflective of what they're doing. Okay? This one, if I wanted to, I could put output the individual employees payroll info. Okay? That might be a little overkill because it's called output IND payroll info. I could have changed that from output IND. I could literally have put the word individual in there. And then we could have called this one down here all employees, or output final totals would have probably been a better name for that. Or output accumulators or something like that. All right, but I'm going to grab that comment that we have up here, copy it to the clipboard, paste it in down here. And I'm going to change it to output the employee accumulators info. It's not that important that what you say, but the litmus test, again here, whether or not you need a comment is, if you have to ask, do I need a comment, you probably want to put one there. All right? I honestly, I'm telling you this, and you're going to think you're making this up. I can't make up stuff like this. I told students when I first started to teach, I want everything commented that you think needs a comment. And I'm not kidding you. I had a student that in most of their blank lines, they put a comment in that said, this is a blank line. Not only is that overkill, once you put a comment in there, it isn't blank anymore. Why did they do that? I don't have a clue. But they did. All right? So now we've got our main done. I will tell you something. Please look up on the screen, everybody. Normally, we wouldn't write it like this. Or what we do would be to take all of these lines right here. Everything that we've got right there up to here. And we would comment those lines out. Any guess as to why I would comment those out? How about because I want to test one of these at a time? By putting those in there, I'm testing all 6 of them. So now what I can do is I can go back to my payroll 3 example, and I can find where I said first name equals this. All right, I can copy that. I'm going to change this in just a minute, but I can come back in here now into my input first name info, and I can do this. All right, so now I've got input first name, and that's the only thing I'm calling. So if I save this and I run it, oh, I don't want to run that one. I don't want to do that either. So if I go back to my test 4, okay, and I run the program, first name, Jeff. Do I want to run the program again? Yes. So that's going to allow me to keep putting in first names. Does that make sense? All right. Okay, what if I do this? Okay, what if I come in here and I type in this? Did I just type in anything? I hit the space bar. All right. It used to be the way that when people started writing HTML forms and they said these fields are required, and you had a person who was lazy or didn't want to give certain information, they would hit the space bar for those forms. And guess what? If you didn't write it well enough, the program took that. Okay? Because it wasn't, you say, what? It wasn't blank. Well, that's a blank. Not as far as the system is concerned. It's looking at the length of your input, and you had a value in there. All right? Not only that, sometimes people put in this. Hit the space bar a couple times, Jeff. Hit the space bar a few more times. Now, if I allow that technically what that does is now my first name is space Jeff space. You say, well, that's stupid. All right. But that's the way that the program is currently written. Does that make sense? All right. Now I have to check something. I don't want to run it again, so I'm done. All right. I want to check because I want to double check this. Does JavaScript have a trim function? Have a built-in trim function? String.prototype.trim. JavaScript string methods. So I came in here and I looked under JavaScript string methods, and I looked for something called trim. And it says I've got length that tells me how long something is. I've got something called index of, which allows me to search for what's called a substring. So for instance, if I was going through the Declaration of, let's say, let's assume that when Lincoln did the Gettysburg Address, what was that, 7 years ago? Let's say that throughout the speech, he used the phrase 7 years ago, not just once, but throughout it. If I wanted to check through the entire Gettysburg Address for how many times he used the phrase 7 years ago, I could use index of. That's a substring or a string within a string. All right. There's other ways that you can, there's a search function. There's a slice method, which allows you to take information out of a string. Okay, there's a substring method here. Again, these are different ways that allow you to grab, things that are in a string. There's replace. So notice here, this would change please visit Microsoft to please visit W3 schools. All right. There's an upper and lower, which we've already seen. There's a concat, which is like using the plus sign that I've already shown you. There's a charat, which we already looked at. There's some conversion things, complete string reference, but what I don't see in here is a function called trim. Other languages have a function called trim. All right, string.prototype.trim. The trim method removes, using trim, okay. How about this? If we want to be able to remove beginning spaces and ending spaces, we have to type in something like that. See that ugly thing right there? And literally what that does is it says check any spaces that are right at the beginning and get rid of them. Replace them with nothing. Check all the spaces at the very end, all right? And if you find any, get rid of them. I don't want to get into that right now. So what I'm telling you is typically what we do in other languages, not JavaScript, but in other languages, is we would do something like this. All right, where we put this in, we'd say this. Don't you do this. But we would do that. And that would trim any beginning spaces and any ending spaces. Does that make sense? We would do that. Well, we don't have that built in, so I'm getting rid of that. And I don't want to go into right now how to do that and what all that stuff means. I just showed it to you, but I don't want to go into it. All right? So I'm going to keep this in here. So I now have first name equal prompt, and I checked it, right? I tested it. Okay? So now I'm going to go in and I'm going to uncomment out. What the heck happened to the other one? Okay, we had. Now I'm going to put in input last name. All right. Hopefully we had that in there to begin with. I don't know if I think we had them both, didn't we? All right. Now I've got input last name. Well, you know what that is because we had that from our payroll 3. That was just this one right here. All right. So I'm going to grab that one. I'm going to go down to my number 4, and I'm going to paste that in. All right. So now I've got my first name and my last name handled. Does that make sense? All right. So I'm going to go and I'm going to save, and I'm going to come back and I'm going to run this again in Chrome. I'm going to keep running the wrong darn file. All right. So I'm going to come back in here and I'm going to run this. So again, Jeff, Scott, yes. So I could keep putting in first names and last names, correct? All right. So let's say that I did this, and for some reason I wanted, all right, I wanted to be able to test every single one of these. So I wanted to be able to test all of these, all 6, but I hadn't written them yet. Everybody hear what I just said? I want to test all 6 of these. I want to remove this, and I want to, remove the thing that was at the bottom, which was there. All right? I want to call all 6 of these routines, even though I've only written 2 of them. Everybody hear that? I've only written 2 of them. So how can I do that? I can write what's called a stub, S-T-U-B. So I'm going to write stubs for these other 4 functions, then we'll come back and write them. All right, but it's real good because it will take a break first. So I'm going to go into all 4 of these functions, and I'm going to put in here alert in input hours worked function. That's all I'm going to put in there. All right. So hopefully that alert will come up when I run that. Then I'm going to put another one in here. It's going to say I'm in input pay rate function. All right, then I'm going to put another one down here that says I'm in the calculate gross pay function. I'm going to put another one down here. Whoops. That says I'm in the output individual payroll info function. Those are all I care about right now. So I put in 4 stubs. Why did I do that? Well, notice what happens now when I run this. It still comes in and it asks me for a first name. And it still comes in and asks me for a last name. Then it gives me a stub to let me know I'm in this function. Another stub, well, it should have kept going, but I don't know why it didn't. But you get the idea? Sometimes programmers do things like that, all right, because they haven't written their routines yet. So when you do that, it's literally just referred to as a stub, okay? All right. I don't want those stubs in there anymore, and for no other reason, because I've actually written the code. It's 8:57. Let's come back at 9:10, and we'll pick it up there. We're going to finish this one, go on, and then we will pass parameters in. So we won't need those variables to be global anymore. You'll see that next.